Hi guys, it is Miss Claywell here. I am not at school today. I will miss you guys. But we are going to do 8.4, solving exponential equations with common base, through a video. So thanks for following along in your notes. So in exponential equations is where x is the exponent. So you guys are used to seeing, we have some examples on here, you guys are used to seeing x is maybe the base or something like that, like an x squared, but this time it's like a 7 to the 3x. So if we have the same base, we just want to make sure, so these are both base 7. We want to make sure it's written as base to an exponent equals base to an exponent. I have that. So I can move on to the next step. I can just set the exponents equal. So the bases are the same, the exponents have to be equal. And now this is back to solve the equation, back to algebra 1, or this is just a two-step equation. 2x equals 4. X equals 2. Here I have the same base, but I don't have it as base to an exponent equals base to an exponent. So I can remember my exponent rules. If we need to remember our exponent rules, they're on the back of your notes. They are here. So this is actually 3 to the x times 4 equals 3 to the 4th. Once my bases are the same, I can just set 4x equals 4. X equals 1. So that's what it looks like if we have the same bases. We will not always have the same base. And that's what these sets look like when we have different bases. So I'm going to rewrite it with common bases. I'm looking at this and thinking 3 and 9. What would their common base be? It'd be 3. So 3 to the x. I can rewrite 9 as x squared. So I want to write it as base to an exponent equals a base to an exponent. This 3 squared is the same as 3 to the 4th. If you need to remember your exponent rules, go back and look at this sheet. We can, power rule is what we're looking at. On the left, I can see that 3 and 9. That 9 is just a 3 squared. Sorry, on the right side. We can see 3 and 9 are the same. Once I have the same bases, I can set my exponent equal. I don't have anything to solve there, so that's done. On the left side, or right side, 64 and 4, they have the same base as 4. 64 is 4 to the 3rd. Look at that table. If you need help seeing that, so if you want to go back to your table, 64 is 4 to the 3rd. If I remember my power rules, this is 4 to the x plus 3. And then I multiply my exponents. So this is, set the exponents for equal x plus 3 equals 3. 2 plus 4x. And then I just take whatever time needed to share this. I made a mistake. Sorry, this would be 12x. Divide both sides by negative 11. So x equaled 3 over negative 11. So go ahead and flip to the back page. We're going to do some more with different bases that we have to make the same base. So 6 and 2, 16. We can see this have a base 6 in common. Once I have the same bases, I can set my exponents equal. If you need to show less steps, that's fine. Um, so should we get an x equals 17? 12, 8, and 16. You can look at your charts. These both have 2's in common. This is 2 to the 4th. So I'm going to write with my same bases. I can just cross off my bases once they're the same. And x becomes negative 24. So as you look at example 4, you're asking yourself, what is my common base in between 4 and 16? As we look at the common base between 4 and 16, we see that it's 4. Actually, I was wrong. It's not, yeah, you can do 4, or you could have done 2. So either one of those would have worked and gotten us the same answer. So you could have set this up 2 squared and then 2 to the 6th. So either one of those would have worked. I'm going to continue with this one. Once our bases are the same, we just set our exponents equal. we end up with an x equals -8. If you thought of it in terms of twos, that's fine as well. The last ones we're going to do are 4 and 5. Notice that they both have negative exponents. So I'm going to start by looking at these as 32 and 16. They both have, I would write these both with 2's in common. And it's not 2 to the 5th, it's 2 to the -5th because it was in the denominator. So that's the only change when we have negative exponents. And now that my bases are the same, I can set my exponents equal. And if you need or want to do this in less steps, that's fine. So the last one we'll do together is 9 and 18. They both have a 9 in common. So I'm rewriting them both as a base to an exponent equals base to an exponent. That's just 9 to the -1. There's an invisible 1 there. Then I can set my exponents and solve these like a algebra 1 equation. So, go ahead and start your homework once you're done with this. I am happy to answer any questions in office hours next week, or we'll review this in class as well on Tuesday when I see you guys. Take care. Bye.